Yeah, so hi everyone. In today class we'll learn about typecasting. So let me start with a simple example. Okay. So let me go down first. Okay. It's not take. Okay. So I'm taking a operand 1. Okay, which I'm going to assign operand 1 and then operand 2 I'm going to assign to operand 1. Okay, so here operand 2 is the source, operand 1 is a destination. We are assigning source to destination. Okay, so usually source type must be same as a destination type. Okay, if any scenario when source type is not same as the destination type, then source type must be converted to destination type. Okay, and basically this process is calling typecasting. Okay, so we can say that the process of converting one type to another type is called typecasting. Okay, so in the diagram you can see that the typecasting we have two type, implicit typecasting and explicit typecasting. Okay, so implicit typecasting, when typecasting is happening automatically by the compiler, that is called implicit typecasting. Okay, explicit typecasting, when the typecasting is done by the programmer explicitly, right, then we call it explicit typecasting. So if you can see the example here, explicit, I'm taking int a equal to 10, int which is a bigger data type than byte in the term of range and size both. So when you assign int a to byte, so you have to do this, you have to follow this syntax to convert explicitly. So what I'm doing, I'm taking int a here, I'm writing the data type in which I'm trying to convert, okay, the destination data type, and then general variable declaration that we have for byte. Okay, so because a here a value is 10, which is falling in the range of byte, that is the reason even with the help of explicit you are able to assign that 10 to byte. But if there is 300 or 400 more than 127, if you have any value and you try to do explicit typecasting, there you will lose some bits that we'll learn later in this class. Okay, now come to the implicit pretty straightforward. When you are having a smaller data type value, you are assigning to a bigger data type. Let's take example byte a equal to 30. So byte size is also less, as well as byte range is also less compared to int. So that is the reason you can easily assign that, and there in any scenario there is no loss of bit. Okay, and without losing your data you can easily in implicit way you can assign that value to int. Okay, so now if you see that what is happening, like we have seen implicit and explicit, two things is happening, lower to higher and higher to lower. Okay, so that is called conversion. When you are converting lower type to higher type, we call it widening. Okay, so when you are going lower type to higher type, we call it widening. Okay, so you can see here byte b equal to 10, and byte is a smaller data type that we are assigning to int a equal to b, means we are doing a implicit casting. Okay, we are doing a implicit casting, and because we are assigning lower type to higher type, we can call it widening also. Okay, so if you see that because it's lower to higher, this is also valid, and the second line is also valid, so both the lines are valid. Okay, but if you see in the case of narrowing, when we are assigning higher type to lower type, so what is higher type here? Integer is a higher type and I'm assigned to lower type. So what will happen? So if you write in the program, if you see you have int a equal to 300, right? When you assign here byte b equal to a, so byte range is what? Byte range is 127. So what will happen to 300? Okay, so first of all, directly you cannot assign. Somehow in explicit way you can assign that one, but in that case also, because byte range is 127 and you assign 300, so you will lose a data, right? You lose a bit. So how we'll lose a bit, we'll see. Okay. Next. Okay, so how we'll lose a bit, that we'll see. So basically what happened? So a equal to 300. When you assign it to byte, it will become 44. Okay. So means we assign a value 300, but it's become 44. Why? So first we'll see that why. Okay. And then we'll go through some example. Okay. So let's take an example. So what we are trying to do, we are having 300, right? So 300, we are having, sorry, int a equal to 300, and we are trying to convert this 300, or we are trying to assign this 300 to byte b. Okay, so now when I'm assigning this to byte b equal to byte a, so in this case what is happening? So for byte b you will have value 40 when you do system.out.println. So why, how it is happening, that we have to understand. Okay, so we'll take one example. Okay, so let's assume what we'll do is first we'll convert this a equal to 300 to their 32-bit memory representation. Like if you save this 300 into memory, how it will get saved? So basically it will get converted to binary. Okay, it will get converted to binary, and because int is having 4 byte of memory, means it will take 32-bit memory, so it will, that binary representation will get saved into 32-bit memory representation format. So we'll see. Okay, so let me do this first. Okay, so 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32, right? So let's start from 1 2 3 4 5 6 7 8, let me take this, 9 10 11 12 13 14 and 16 17 18 19 20 21 22 23 4 5 6 7 8 32. So total 32-bit memory representation we have. So if you convert, you can convert, and you see when you convert 300 into their binary representation, so what will happen? So you will get, okay, one second, let me change the color so it would be easy for you all. So first you will get 0, then 0, then you will get 1 1, then you will get 0, then you will get 1, then again you will get 0 0 1. Okay, so 00 11 0 1, one second, 00, okay, correct, 11 0 1, second, I think. So we have 0 0 1 1 0 1, then 00, then 1. Okay, okay, and then we have 0 0 0 0, So 0 0 0 0 0 0 0. So till here it is 0 0 because I have to represent this one. Okay, so what will happen now? We are going to convert this to byte. Okay, so byte. So we'll take this is 1 2 3 4 5 6 7 8. So we'll take 8 bit. Okay, so now we have byte b. So byte b having a 8 bit memory representation: 1 2 3 4 5 6 7. 1 2 3 4 5 6 7 8. So 1 2 3 5 6 7. 1 2 3 4 5 6 7 8. So we'll remove this. Remove this. Okay, so we'll see here. We'll take 0 0 1 1 0 1 00 because we cannot take after 8, so we have taken 8 digit representation. So now if you see here, so we have to look for most significant bit, which is leftmost bit. So this is our leftmost bit, which is 0, means this is positive number. So if the leftmost bit is 0, then you just have to do, you have to convert this binary. Okay, you have to convert this binary into decimal. Okay, so let me convert this binary into decimal and see what we'll get. Okay, so we'll start with a simple. Okay, so we'll start with this one. So we'll start with 0. From here we'll start. Okay, let me change the color so you guys will get the good idea. So we'll take, first we'll take 0 and then 2 multiply with, because this is 0, so multiply with 7. Okay, now why 7? So it's like I have written here 1 to 8, but basically it is like 0 to 7. Okay, so it will be 0 to 7, so that is the reason. Okay, plus 0 into 2 power of 6. Okay, plus 1 into 2 power of 5, plus 0 into 2 power of 4, plus 1 into 2 power of 3, plus 1 into 1 to 2 power of 3, plus 1 into 2 power of 2, plus 0 into 2 power of 1, plus 0 into 2 power of 0. Okay, so if you calculate 0 into 2 power of 7, what will become? It becomes 0. 0 into 2 power of 6, 0. Okay, 1. Okay, so 1 into 2 power of 5, what it will be? It will be 32. 0 into 2 power of 0. Okay, plus 1 into 2 power of 3, that will become 8. Okay, then we have 4, 2 power of 2, it will become 4, plus 0, plus 0, because 2 power 1 and 2 power 0, if multiply with 0, it will become 0. So what we will get? So we will get here 44. So that is the reason when you convert, when you do this int a equal to 300 and byte b equal to, sorry, if you do here and then you print B, you will get 44. Clear? Right? Okay. But so let's take example. If you have int a equal to 130, okay, and if you convert this to byte, so that is byte, b equal to byte. So here we are doing explicit conversion, and we can also call it narrowing. Okay, so when you print this one, right, you print b, the output you will get is, you will get 120 minus 126. Okay, so why you will get 126? So this is also pretty straightforward. Okay, so first, if you want to know why we'll get minus 126, first we have to do, we have to convert 130 into their respective binary representation, and in 32 format memory representation also required. Okay, so we'll see it. Okay, so we'll get 0 0 0 0 0 0 0 0. Okay, and then again we'll have 0 0 0 0 0 0 0 0. Okay, and again we'll have 0 0 0 0 0 0 0 0. Okay, and then we'll have 1 0 0 0 0, so it's become 0 1 0. Okay, so clear. So 1 2 3 4 5 6 7 8. Okay, so as we know that this is a 32-bit representation, when I'm converting into byte b, so means first we have to take 8-bit memory representation. So 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. Okay, so let me fill this. So I will let me change the color. So I will take this one first here, 0 1 0 0. I've taken this, and 3 more, 0 0 0. Take one, this one. So as we have seen the previous example, MSB, which is most significant bit, which is 1, which is the leftmost bit, right? So this is the leftmost bit. Okay, so 1 basically it's showing that it's a negative number going to be. Okay, so if it's going to be a negative number, okay, so if you get 1, so you cannot directly convert this into the decimal. So first what you have to do, first you have to perform 2 complements. So everyone aware about the 2 complements, right? 2 complement. Okay, so first let me perform the 2 complement. Sorry, it's 2 complement, and then we'll see how it's going to be. So we'll take the number. So number is 1 0 1, and then there is 5 0, right? And then we have 1 0, right? When we convert, the first what you have to do when you are going to perform 2's complement, first we have to convert each bit. Okay, just convert it, 0, and then 1 2 3 4 5, then again 0 and 1. Okay, so if you count 1 0, and there is a 5 number, then 0. Okay, now this is the step of second complement. So we have just inverted step 1. So we have inverted all the bits to Just 0 to 1 and 1 to 0. And then what you have to do, we have to add in step 2, add 1 in the sense the binary 1. Okay, so I will add 1 to this. Okay, 0 double 3 4 5 0 1, and now I'm going to add 1. Then what is going to be equal to, so basically when you add this, so you will get 0 1 1 1 1. Okay, then you have 1 1 1 0. Okay, so okay, so now what you have to do, you completed the second complement, right? That's we call 2's complement. So we have with this, with the 2 step we have completed it. The step 3, the result is step 3. Okay, so now what we have as a result, so we have result 0 1 1 1 1 1 1 0. Okay, so basically 3 3 6 number, this one is extra. Okay, okay, so 6 number we have, 6 ones we have, and then we have in 0 6 6 1 and then 0. Okay, so when you convert this, right, you will get 126. That is their decimal representation. I hope you all know how to convert from decimal to, sorry, from binary to decimal. Okay, if you guys don't know, you have to go through some YouTube videos, because I cannot explain it here. Okay, so step 4, what is the step 4? Since the original byte had a sign bit of 1, as I mentioned here, right, this is right, sign bit of 1. Okay, so original byte had a sign bit of 1, it is a negative, so the value is minus 126. Okay, okay, so now question is how it's become minus 126. The reason is byte can only store value between minus 126 to 127. When the int 136 is cast to byte, it's a wraparound due to overflow. In the 2's complement system, okay, in the 2's complement system, if you see this value, right, when you converted first 1 triple 0, then double 0, then 1 0, which is 126, which is 130, right? So in 2 complement system, it's become minus 126. Okay, so that is the basic summary of that. So it's called narrowing. Okay, and narrowing will get performed in 2 ways. If sign bit is positive, means directly you can convert that binary to decimal. If it's negative, you have to perform, first you have to get the binary, then you have to perform second complement, whatever value will get convert to decimal, and then add minus to that. Clear? Okay, thank you.